Thanks a lot, Murthy, for sharing those very touching and moving memories of Venkat with us. So our last scheduled speaker is Dr. Aditya Roy Chaudhary, one of Venkat's more recent students who got his PhD from the semiconductor group. And Aditya is currently a postdoc in TIFR Bombay. Um, Aditya.
Hi, I hope I am audible.
Yeah, you're audible and visible.
Okay, yes, I know I am visible. Thank you. Thank you to all the organizers who have made this possible. Yeah, so I am currently not anymore in TIFR. So right now I'm at IIT Bombay. Okay, so I will try to present very less content. And maybe because of that, I can take the privilege of speaking a bit slowly. So many, and you can stop me whenever you want. I think if I go at a decent pace, I'll finish within 2-3 minutes after I start, showing you my slides. So I made the slides mostly on the memories. Like, I mean, they don't really discuss much of the work that we did. So, but many people spoke about the work that they did, and like I can maybe just take you down the memory lane from the point of view of the work, the research that happened during my PhD. Before I start presenting the more memory-oriented slides. As I told you before, any of you, especially Professor Mukherjee, can stop me whenever he wants. So that's not a concern. All right. So I did not do a BSc or MSc in physics. I was doing my engineering in a material science subject. And there I came across both branches of science and engineering. So I sat in GATE in engineering sciences and I qualified for the physics department interview, where actually things turned out quite well and I got a chance. So when I asked sir, by sir I mean Professor Venkataraman, I don't know any physics, but I'm very interested in it. And what do I do? So he said that you do one thing, you just make sure that, whatever you do come to people's use. There are many theses which are being written and have been written from this department which lie idle among dust, and you try your best, like as I tell all of my students, to make sure that for your thesis that is not the case. So then it all turned out that my topic was very simple. I just had to experimentally measure something which had been theoretically postulated based on a very simple calculation more than 50 years ago and is very fundamental. It's basically Fermi level. And he said that the Fermi level depends on magnetic field. There's a very simple calculation. Why don't you try to prove it experimentally? So it was as simple as that. So when I tell you about the experiment, it's even more simpler. It's basically like you have a semiconductor, and when you change the magnetic field, its Fermi level is supposed to change. And the Fermi level's external manifestation is in producing a potential drop or a voltage. So if you have basically a voltage source, you could measure it. So then why I am telling you all these things is this, that then he said that why don't we do one thing? You calculate how much magnetic field we need. Okay, and the calculation came up to be something like 6 or 7 Teslas, which easily the pulse magnet can go up to, but only in promising materials which had high electron mobility like gallium arsenide. So I said, wonderful. But then he said that, but you see, it's going to produce a voltage, but to measure it with a voltmeter, you need a reference. So you'll probably need to, keep that piece of semiconductor in a place which both has 0 Tesla and 7 Tesla. So I said, how is that possible? He said, see, it's a very interesting thing. Why don't you think about it? And then he left. So I was breaking my head regarding what to do with this, because it was impossible to find a space where you can have magnetic field gradients of that order of magnitude, like across some, even if the semiconductor is a grown crystal, even if I take 1 centimeter, you cannot have 7 Tesla and 0 field across 1 centimeter. So later, the solution came out to be very interesting. Actually, I also found it in the literature. Some people have tried it 50 years back. They didn't succeed with the experiment. It was tough to do. It was tricky to do. I won't use the word tough. And it was very long. So all that was there. But the trick was you used a different material which would not change its Fermi level by such a huge extent. Okay, so basically we had a metal and gallium arsenide stuck together, and we will put it in the magnetic field and just short them and measure the current. Okay, so just to make sure that it didn't short internally, we put an insulator in between. So that resulted in what we call a MOS device, metal oxide semiconductor device. So why I told you all these things, because, like it was a long PhD. It was a wonderful experience working with him. That's mostly because he never stopped me from trying out any new thing. And why I'm telling you all this is because it was very simple. It was so simple that I could actually explain my work to a class 10 physics student. Okay, so it was very simple, and things turned out very nicely. So that was what I worked with. I basically experimentally found the Fermi levels magnetic field dependence for the first time. And also from the departmental point of view, it was quite cool, actually, that we did. But apart from that, physics wise, it was not a huge work, because we had done was to experimentally show that a theory works. Okay, but the work has even now, it has a lot of promise. It's mostly because it matches with theory only within the given order of magnitude. Okay, so if it can be done again in different materials, one can possibly find out a lot of different things. So I hope that I am not going to run my given time. Having said that, I can maybe try and start sharing my screen now, and we'll complete the presentation of memories, which is not too much work oriented. I think which is not work oriented at all. Within a few minutes, I'll try to do that. Let me try and share my screen now. So I'm clicking on the share button.
No, we still can't see your screen. We can see you.
Yes, I'm very sorry. Just let me try a bit more.
Right. So I think after you click on the share button, you might
your
also
entire screen.
Right.
Okay.
I think something is showing up now.
Is it a PPT?
Well, no. I mean, we can just see the circle with your initials. Okay, now there's a black. Okay, now we can see. I can see the PPT. Yes, go ahead.
Okay, so can you see the slide called Remembering, sir?
Yes, yes.
Thank you so much. All right, so in the very beginning, let me please tell you that I have never given this kind of a presentation before in my life. Whatever presentation I have given before are all on specific professional things, like based on work. This is more or less an emotional rambling, and I try not to give presentations when I'm not confident about what I'm going to say. Okay, so my this 4 or 5 slide presentation, I will try to make you smile a bit. If you don't want to laugh also, I hope that like you don't find what I'm presenting to you weird. You may choose to think about it later in your free time if you remember my slides at all. And of course, you cannot throw things at me because there's a computer screen in between, so I am saved. So it's called Only Time. it basically collages basically collages 4 memories which happened only once in the 8 years. So I've named it only time, and then I'll fill it up with this has happened. All right, because it's called only time, I should first tell you that it has nothing to do with Enya's song, which is also called only time. Enya is a wonderful singer. This is Enya's photo and the advertisement for only time. It's a wonderful piece of work also artistically. Okay, so many of you may find this very weird, but this was a long chocolate. Okay, I got it from Texas. 2014, I went there for a conference in ICPS, and I especially got it for him because I always found it a bit embarrassing to give something to him. So I thought, why don't I give him this 1 foot long chocolate? This was literally a 1 foot long chocolate bar. Okay. And I literally chose that size so that I thought that, like I have seen his family members, his wife, ma'am, and his daughter once or twice in the meeting gatherings after the thesis, have been submitted by some of our group members in the past. And I thought that, okay, anyway, I don't know them, so I cannot give them anything. I've come out of the country for the first time, and I can get this big one for him so that, he at least shares with them. He unfortunately did not. Okay, so I heard that he ate the full bar himself on one afternoon. Okay, so this is 2014. All right, so this is the second of my 4 memories in 2013. So this is the magnet to the right, and following Bhaktosh and Murthy's footsteps, I learned making magnets, and finally it worked. So it's one of those magnets, and so the funny thing is, I always used to be in lab. I was one of those guys who never left lab, like having emotional connection to my work, which today I only understand that I could have, spent my time much better. But at that time, I was not like that. So I actually watched a lot of this TV series on, we didn't have Netflix or Amazon Prime at that time. So I remember watching series like House MD, Breaking Bad, so whole day in lab. So I do not know whether it has any connections to my staying whole day in lab, but there were a lot of, my area was actually very dirty. Okay, so at least I didn't have any food packets here and there, but other than that, it was filled with insects. They used to come there, spend a weekend, like with their young ones, especially spiders. They never stopped building their webs there. So one day, he just came to me, sir, and his own way, he said that, Aditya, I think you should clean up this place. Okay, so I cannot afford any visitors to come in the lab and to find these spider webs. So that's what he told me. But that was the only time he stopped my planned experiment. Okay, my experiment was to check whether the spiders had anything to do with magnetic field. Okay, but anyway, that I could not do. And I mean, like, truly speaking, the spiders used to come only to the magnet. Okay, so they didn't visit any other places. Any other places in the lab was also completely unvisited by them and their webs. I didn't know what was so special about me and my setup. So I wanted to do some experiments, but anyway, those didn't happen. Okay, so to go ahead with my ramblings, I can give you a small intermission and quickly tell you 3 interesting things about Sir. Okay, I hardly think that anyone will tell you these, but because that this is hopefully getting recorded, I think it's good for people to know about Professor Venkataraman, these 3 points. One is he was a very good judge of which paper can be published where. So papers seldom went to a wrong journal. They were also hardly rejected. Okay, so he was never over ambitious. He knew exactly where a work belonged, and he worked towards it, and he submitted there, and they accepted. That's what happened. He was also too good at guessing which problem will work. So seldom we young PhD students used to have complete faith in his belief, and we used to go ahead and spend 3 or 4 solid years working, just believing that one day we will achieve our goal, and finally that used to happen. It worked like magic. Okay, so he could do that, probably what you say, thought experiments before we did our actual experiments, to know that the signal will come, won't stay buried in noise forever. And the third thing is he explored very new things. I mean, like many of the topics were absolutely unpublished. So these 3 things I wanted to tell you about, especially. Now I go back to my ramblings. This is the second last slide. So things were loud in the lab the only time when my transistors started blowing up. They made sounds like firecrackers. You see a transistor board from the magnet that we had and maybe still have, the physics department. I'll be very happy. This is just informally sharing what I, sharing from my side what I can say in a public platform, very informally. I will be very happy if this magnet can go to people's use in a widespread way, in whatever way, and I'll be comparatively less happy if this ends up in someone's storeroom and stays locked up. Okay, so now this is a IGBT board, insulated gate bipolar transistor board, which actually switched the high currents to make flat tops out of it. It's a very interesting design. We published it in 2012. So while trying with it, these transistors blew up. Okay, they were, we had to put snubbers. We had to, I of course don't expect you to know what snubbers are if you already don't. So we used to put we had to put snubbers. We also had to try Schottky diodes as crowbar diodes, because otherwise PN junction diodes have this knack of storing a lot of free carriers while they go on and off, and that gives rise to a lot of timing problems. They cannot switch very fast. This is a standard UG textbook question about diodes. So because of this snubber and crowbar Schottky thing, this transistors used to blow up. Okay, so they don't blow up anymore because we put the snubber and the crowbar Schottky. They used to blow up when we didn't. So only during working with them we understood we had to do this. So they used to blow up. There were fire on the tabletop, and there was sound. Okay, so they actually blew up like crackers. So that was great fun working in the lab, especially under sir. And things were loud. It was the only time when things were loud in the lab. All right, now coming to my last memory in 2012. Okay, so this is what happened. Okay, so I still don't have any clue of what it meant. Okay, so the cartoon which shows a guy with a medal and a cup is probably me. I was feeling victorious. That was my first paper after 4 years, mind you. And the first paper was so good that the reviewer actually sent back with some grammatical corrections. There were no other corrections to it. It's exactly what he has asked me to do, and I had done. Of course, I had my own contributions in it, but it's mostly driven by him. So that was my mood at that time. After the paper got published in April, I think it was 4th of April 2012. It came out online. So it showed for the first time a tabletop magnet which could go up to more than 1 Tesla and still have static magnetic fields, of course, within a short time window. So it's called control waveforms. So anyway, so now I was feeling like that. And then he suddenly called me to his office one day, and laughingly he asked, Aditya, what have you planned to do after this? So That was 2012. I joined in 2008, but I remembered that he told me, like working under me will take some time. So I was actually planning for 8 or 9 years. So anyway, my stipend would stop in another 1 year in 2013. So I was suddenly startled. My joyous feeling vanished, and I came down to earth, and I said that why? We had a lot of work. I mean, we had the full Fermi level problem remaining at that time. I was still struggling how to get the noise reduced, the pickup noise. So he said that, there is this a guy called Josephson who did wonderfully well in his PhD. And then after his PhD finished, he went to see some monastery. He was not in research anymore. Do you have any plans like that? So I was completely taken aback. I didn't know what to say. So this is probably the only time he said something too deep, whose meaning I didn't understand. When I look back at it, I think why he asked was probably because he was probably planning some teamwork with me and others with that magnet. But anyway, that somehow maybe didn't happen right at that time, or maybe didn't happen. But finally, we could collaborate with many people from one group, from especially Professor Vikramjit Basu's lab in biology, who used the time varying property of the magnetic field fantastically to his applications. So yeah, so that was that. So he said that, I mean, Josephson went to see the monastery. Do you have similar plans? So I mean, like, I didn't get anything out of what he said. Okay, so those are the 4 memories, and this is a few things about me. I know it doesn't make any sense at all, and you can close your ears for the next 30 seconds. But given that I told you about Sir, I think I should also tell you about me, because it's me who's basically speaking these things about Sir, so that you can also get a reference frame. I like learning about new things. They include both experiments and theory. And I also like doing research on my own. So like I'll be very happy if somehow I am made to depend on the minimum number of people for my research. Of course, I am a great fan of collaboration, because I learning new things, but that's how I am. Courage to explore was Sir's biggest gift to me, and I console myself saying that it was as big as the Texas chocolate was. Okay, because that's what he gave me, and that's what I gave him. So yeah, thank you so much for giving me an opportunity to speak. I will quickly hand over the mic to someone else. Thank you.
Thank you very much, Aditya, for that very nice and poignant and colorful presentation. So we're sort of at the end of our scheduled program. We could maybe go on for another 10 to 15 minutes. So if there's anyone who would like to say something quickly about Venkat, please let me know. What you could do is you could use the hand raising tool, if you can locate that.